So the formal definition of complex number or imaginary number is this. Z equal A plus BI, where A and B are your real parts. When I say real parts, mean it belongs to the real numbers. And I is your imaginary part. So let me give you an example. Example will be 3 plus 2i. That's complex number. Right? 3 is A, 2 is B, and I is I. Or 5 minus I. That's your complex number. It is complex number. Why not? Okay, look at, I can write like that, right? It is complex number, right? Even though you don't see the BI part. What does it tell you? What does it tell you? That means all real numbers are complex numbers, right? So I say number one, you can rewrite 1 plus 0i, right? So all real numbers, all imaginary numbers. Not the other way around though. What about this one? It is complex number. Two I. Yes, right. So I can rewrite it as 0 minus 2i. Now, complex number have their own plane. What I show you so far is real plane. You have x and y, right? Complex plane looks like this. You don't have to know this. You don't have to copy it down. You don't want to. Where the horizontal axis will be your real part, your real number, and the vertical axis is the imaginary axis. So for example, if I want to plot 3 plus 2i, so 3 will be on the horizontal axis. 1, 2, 3, and then go up to 1, 2. So that's 3 plus 2i right there. So that's kind of similar to x, y, z axis. I'm sorry, x, y axis. We only talk about two-dimensional plane here. All right, so that's the introduction of complex number. Difference of two square. You guys know this from 661. If I have a squared minus b squared, I can expand it as a plus b times a minus b. This is real number. What about a squared plus b squared? So far, you taught a squared plus b squared is prime, right? But if I say x squared plus y squared and I ask you to factor it, you say prime. Right? It's prime because I only asked you to factor in real numbers. However, in complex number, it is not prime. It is equal to a plus bi times a minus bi. And we can check why this is true. You can check by formula. Right? So say a times a is a squared. Don't write this down. It's a squared. A times negative bi is negative abi. Bi times a is the same thing as abi. And last, bi times negative bi is negative bi squared. The middle term cancel, yes? What about this one? What about that one? Well, that's gonna be b squared, I squared. What's I squared equal? Huh? What I squared equal? Yeah, -1. I equals square root of -1, right? And you square both sides. I squared equal -1. So I squared is -1, so I have negative bi squared. Well, negative bi squared with the black negative in front becomes positive. I'm sorry, it's -1, so I don't have to write I squared. Become positive B square. So your answer will be A squared plus B squared. Of course, I just showing you that it's true. You don't, it's not like something that's gonna be on your exam. You have to write that down. Square root property. If I have x squared equal k, if I take square root both sides, when you take square root both sides, don't forget to add plus and minus into one side. Whichever side you like, usually my habit is to add the plus and minus on the right side. Let's take a look at number 1a. I'll show you 2 ways of solving 1a, and I'll show you what way I like better. Usually is left writing for me. So for 1a, I can use the square root property, right? I can add 100 both sides. So x squared equal 100, and then I take square root both sides, plus and minus. So x equal plus and minus 10. Then I'm done. Another way I can do like this. I can factor, right? So x squared minus 100 is the same thing, x squared minus 10 squared, right? A is x, b is 10. Now I can expand it. A plus b times a minus b. So a plus, I'm sorry, should have used x. So be x plus 10 times x minus 10. What does it imply? It imply what? Either x plus 10 equals 0 or x minus 10 equals 0. Right? Or x equal 10, x equal -10. You got the same answer. For me, I prefer the left method. It's just shorter. Less writing. Anyone have an answer for B yet? Very good. So x squared equal -49. Square root both sides. Plus and minus. So x squared is x. And then plus minus. Let me write it slowly. So square root of -49, I can rewrite it as square root of -1 times square root of 49. Well, square root of -1 is I. And then square root of 49 is 7. So 7i. Okay. I think these are review, right? Let's just review. What about C? What you guys got for C? Very good. X squared equal 3. Square root both sides. X equal plus minus square root of 3. D will be you try 1. The due date for you try for today is until Sunday night. Cause it's not on exam too. I'm not gonna rush you to doing it. Right? So you just wait till you're done exams, okay? Now, number 2. What is different between number 1 and number 2? Yeah, but what else? What else different beside the instruction? Huh? Yeah, the number 1 is equation, right? Number 2 is expression. So those two are different things. When you have equation, you solve. When you have expression, you do not solve. So I see this a lot in 661 and 62. They just kind of really tempted to just solve it, even though they don't see an equal sign. They just kind of add an equal sign to the problem and solve it. But don't just factor and simplify if you can. You only saw it to see two sides. Someone factor the first one for me. Very good. I'll write that step as well. And how about the second one? Anyone have the answer for the second one? Close. Close. Yeah, it's the I, right? You know, I know it's not equation, but just imagine you move the 100 to the right, right? It's become negative 100. There's no number that when you square, you get negative. So it's got to be imaginary. Right? So when imaginary, you add the little I next to the factor. So x plus 10i times x minus 10i. And if you FOIL it back, you should get back to x squared plus 100. What about C? Yeah, I always write this part. It's a good habit to have that part first. Right? So you identify what is your A and what is your B. Right? So x plus root 7, x minus root 7. You try 2. Be careful when you do you try. My given answers are similar. They're different, of course. I just kind of move things around a little bit. Have you heard of conjugate? Yeah. What is it? You don't have to give me the definition, the formal definition. Just tell me how you understand conjugate. In the middle, right? In the middle. Now, conjugate is not opposite. So let me show. So let me. So complex conjugate. If I give you a plus bi, and I ask you what is the conjugate of a plus bi, all you have to do is change the sign in the middle. So a minus bi. That is not opposite. Opposite of a plus bi is what? Negative a, negative bi, right? Because you have to add the negative front. But it's called conjugate. For notation wise, conjugate is like this. If I give you a plus bi, and then I put a little bar on top, like that means I'm asking you, write me the conjugate of a plus bi. So your answer will be a minus bi. Just instead of saying conjugate, just put a little bar on top. So, what conjugate of 2 minus 3i? Yeah, 2 plus 3i. What's conjugate of 5? Okay, who said negative 5? Raise your hand. That's okay, I just want to know. Negative 5, positive 5. What about the rest of you? It's positive 5, right? So I rewrite this, it would be 5 plus 0i. And when you change the sign in the middle, it's still 5 minus 0, it's still 5. Right? What conjugate of 3i? Yeah, negative 3i, right? So this is 0 plus 3i, so the conjugate would be negative 3i. just apply the formula. It's just something you don't have to know, really know about it. I just want to introduce you. to complex number, that's all. Let P is the polynomial with real coefficient. In real number system, the polynomial P of x has at most n real zeros. Why at most? Why is it most? Let me show you with the with decimals. Oh no, I didn't save it. Oh, I didn't save it. Let me try this one. Let's see if I have anything. Let me change this up a little bit. Oh, this one. This one's good. That one right there. What is the degree of this problem? 5, and then 2 more, so 7. 2 more is 9. Now, remember, you only care about the first term of each factors, right? So 9. So you should see what 9 zeros, right? You should see 9 zero on the graph. How many zeros you see there? A few, right? No, I'm sure it's not 9, right? I see 2 there at the 2 and the 5 here, but I don't see the last 2, right? I don't see the last 2. I see 7 there, but I'm missing the last 2. That's why they call you only be able to see at up to n 0 on the real graph. If I would have changed this into a complex graph, you would see all 9. Right? You will see the 2 too. But these are complex ones. So that's what they meant by up to n degree. I guess I have too much stuff on it. Mostly school stuff. For a complex number system, you would see exactly n zeros, right? You see all of it. You see all of it. The real and the complex. Why we see all of it on the complex system? Because what I said in the beginning, all real numbers are complex numbers, right? So everything on complex numbers is shown. Fundamental theorem of algebra is really important theorem. Yes. It depends on what kind of equation you look. If just like if you look at this, if you look at the general like that, you won't be able to tell. But if I give you factor, like a little bunch of parentheses, you'll be able to tell. Fundamental theorem of algebra is really important theorem. It took mathematicians over 100 years to prove it. They just kind of know it's true, just don't know how to prove it formally. But they finally did it. It said that it's really simple, really. Every polynomial of degree that is at least 1 with complex coefficient has at least 1 complex 0. Let me give you an example. X plus 1. If I solve this, I have x equal -1. Is that a complex solution? Yes, right? All real numbers are complex number. All I have to do is add the little 0 I at the end, right? So any polynomial that have the degree that at least 1, in this case, the simplest one is linear, it will give you 1 complex solution. The reason, the same thing, all real numbers are complex numbers. Now people can argue with me, like Mimi, the coefficient of x is not real number, not a complex number. The coefficient is real coefficient. So people argue the coefficient is 1. However, they say with complex coefficient, well, 1 is the same thing as 1 plus 0i, right? The same thing, I argue the same thing. It's all come down to all real numbers are complex numbers. Conjugate pair. the conjugate zero theorem is that if the polynomial P has a real coefficient, a complex zero, if they exist, must occur in conjugate pairs. Maybe I'll I'll show you this when we come to the example. What it says that for a equation, if you have one complex solution, there's always another pair, conjugate pair. I'll show you the example, what they meant by that. Maybe that'll be more clear. And then last one, you don't have to know 4, but last one. Every polynomial with real coefficient can be factored into products of linear and irreducible quadratic factors. Like the example I showed you earlier, don't write this down. In decimal, x to the 5th, x minus 2 squared, and then x squared plus 1. Every polynomial with real coefficient can be factored into product of linear. So you see the x and then x minus 2, those are linear, right? And irreducible quadratic factor. The last factor is irreducible. X squared minus plus 1 is irreducible. So that's what they meant. You will have a real factor and then irreducible factor, which likely is going to be have complex zeros. Factoring, your favorite. Like I said, as long as you take math class, factors always haunt you. Factor polynomial P into factors with real coefficients. I know this is not quadratic, but I can treat it as quadratic, right? It's called quadratic in form. Right? It's similar-ish, not quite, but similar-ish. Can you find 2 number, multiply to negative a and add to 2? Multiple 4 and 2, right? So here instead of x and x, you're gonna have x squared and x squared because you need x to the 4. And 4 and 2, we need negative 2 and positive 4. And they want real coefficient, so we're gonna leave it like that. We're done. Oh, actually we're not done. I can expand x squared minus 2 into what? I can expand it into 2 more parentheses, which is x plus root 2, right? Yeah, x plus root 2, x minus root 2. Remember a squared minus b squared? Okay, so a is x, b is root 2. And now I bring down the x squared plus 4. The reason I'm stopping here because they want real coefficient. Now part B, they want you to factor into complex coefficient as well. So let me rewrite. I don't want to rewrite the whole thing. I just need the answer. So x plus root 2, x minus root 2, and then I have x squared plus 4. And for the x squared plus 4, what can I extend it out? Yeah, right. That's what they meant by complex coefficient. So here I can expand it as x plus 2i, x minus 2i, and then bring down the rest. Okay, nicer. So you understand when they ask you to factor in real coefficient versus complex coefficient? Yeah. I can see that you tried. For each linear factor, state the zeros, their multiplicity, and whether the zero represent an x-intercept. All right, so each factor, so I actually gonna, so my factor will be what? But by the way, if they're the same, do not write it twice, okay? But they all different here, so we're gonna write it down. So my factor, the first one will be x plus root 2, x minus root 2, x plus 2i, x minus 2i. What is the multiplicity of x plus root 2? 1, right there. X plus root 2 to the first power, so 1. The multiplicity of x minus root 2 is also 1. Multiplicity of x plus 2i's, also 1. And last, multiplicity of x minus 2i is also 1. If you add up together, your total multiplicity will be 4, right? And it makes sense. Your original problem has the degree of 4, right? So it makes sense. Which one represents the 0 on the x-axis? Yeah, so the 0 represent 0 on the x-axis will be the 2 guy. Bless you. Let me rewrite it properly. So x equal negative root 2, x equal root 2, like that. Okay. 0, 0, 0, 0. Do you have any questions so far? It's kind of similar to what we did last time, right? Like I said, it's a good review for your exams, even though it won't be in your exams. Does the sum of the multiplicity equal to the degree of the function? Yes, right? They add up. They all add up to 4. So yes. And the reason being because n equal 4, which is matching the original polynomial. As you can see the graph right there, you only see 2 real zeros. Remember what one of the theorems said, you only see up to n zeros on the real axes. Why don't you try number 3? I'll give you like a minute or so. Try number 3. At the end of the class, I'm going through the worksheet review and emphasize what problem you should be focusing on. I know it's a lot. Three versions of the exams I gave you. I know you have other classes too and live. So I'll tell you what to focus on in case you don't have time to study them all. Anybody want to read me what you have for 3A? X plus 2 quantity squared. I can rewrite it as x plus 2, right? X plus 2, X plus 2. And I don't think I can factor anymore, right? Because that's irreducible. What about x squared minus 2? Yeah. You know what? If it was me, I was debating whether I should factor x plus 2, because I had an imperfect form. X plus 2, well, x plus 2 is the same thing, right? Because I don't want to rewrite it twice. But because they asked to, then let's do that. And then for the last one, because they want real coefficient, last one is complex, so you're going to leave it alone. And for part B, all you have to do is factor the last one. I'll duplicate that. So that will be x squared plus 25 becomes somebody else. Very good. X plus 5i. One more. X minus 5i. Right. We know that this one right here, that is x plus 2, all of that square, right? Just to remind ourselves, it had multiplicity of 2. So for part C, they want each linear factor state the zeros, their multiplicity. You know what? I was thinking I should not factor x plus 2, X plus 2. I had no idea what they. We did both. So on the exam, if you do like that, you're not gonna lose any points because you kind of cover both. You factor it and then you remind yourself is x plus 2 squared. So x plus 2 squared equals 0. So that's 1, 0. Right? It's the same 0, so I'm not gonna rewrite it twice. X plus 2, x plus root 2 equals 0. X minus root 2 equals 0. X plus 5i equals 0. X minus 5i equals 0. The multiplicity of x plus 2 squared is 2, right? And then the rest will be 1. And this should add up to the original problem, which is 6. Which is equal to n. It is, right? It is. If you look at the problem, I have, of course, x squared times x squared x to the 4 times another x squared x to the 6. And you say it match up with the degree of the function. Which one is your real zero? The real zero that represent on the x-axis. Yeah, the four, right? Those four. Those four. So maybe I'll rewrite it over here. X equal -2, x equal root -2, negative root 2, and x equal positive root 2. So far, so good. If you look at the graph of that function, you see three, well, not three, four zeros, real zero, right? At -2 is bounce off, so that's a multiplicity of 2, right? And it go through at negative root 2 and then positive root 2. So you see 4 real zero there, 2 of which is a double root. So when you have a factor form like that, it's easy for you to identify your complex solution. Yeah. But it's not so easy when I give you the general form, right? Which is what you're going to see on the exams. Then you're supposed to convert it into factor form like that. Right, let's do that slowly, one step at a time. Number 5, find a polynomial p of degree 3 with a coefficient that has a 0 of -5 and 4 plus 3i. So I was given the solution, two of them at least, right? So I given one solution is x equal -5. That's my real one. And the imaginary one would be x equal 4 plus 3i. But it's 3 degrees, we should have 3 solutions. How come they only give us 2? Well, let me go back to the theorem that I told you that I'll say it when I needed to say. The conjugate zero theorem. If the polynomial p has real coefficient, the complex zero, if they exist, in this case it does, has at least, I'm sorry, I read the wrong one. Conjugate zero theorem, the complex zero, if it must occur in conjugate pair. It must occur in conjugate pair. So what does that mean? If you given 4 plus 3i, you're supposed to come up with the conjugate of 4 minus 3i. That's the last solution. Right? So even though they don't give it to you, you just kind of come up with it on your own. So the bottom line, whenever you see a complex solution, if you see one, you come up with another one. Okay? And you guys remember what we do last time? These are zeros. These are zeros. I want factors, so what do I do? Subtract, right? Subtract, move everything to the left, so the right-hand side is 0. So x plus 5 equals 0. X minus 4 minus 3i equals 0. X minus 4 plus 3i equals 0. And then you put them together. And now you have a polynomial with degree 3. X times x is x cubed. Of course, they're not satisfied with the factor form. They want the general form. That means we have to solve it. If I was you, there's more than one way to do this. Let's do the last two first. I'm gonna avoid this. The last two complex solution. So x times x is x squared. X times -4 is -4x. X times 3i is 3xi, I guess. 3xi. All right, one down, two more to go. -4 times x is -4x. -4 times -4 is +16. And then last one, -3i times x is -3ix, 3xi. -3i times 4, -4 is +12i. And last, -3i times +3i will be what? -9i squared, right? Here comes my favorite part. You're gonna cancel things. You're gonna cancel, what do I can't see? I see that. What else? That one and that one, right? -12i, +12i. And then I can combine the -4x and -4 become -8x. So x squared minus 8x. Now for the negative I, 9i squared, I can convert it into what? This is -9 times -1, yes? Which is +9. I'll tell you what, every time you see an I square, all you have to do is change the sign in front of the number and get rid of the I. Okay, it's become positive, that's all. So that's +9. We're not done yet. What do we have to do? Oh, the 16, thank you. Thank you very much. I forgot about the 16. +16, so 20, I can't think. 25. 25. Use red for that one. And then you bring down the x plus 5. Bring it down, and then you keep with it. It's not difficult, it's just tedious. Just be careful with the signs, that's all. X times x squared is x cubed. X times -8x is -8x squared. X times 25 is 25x. 5x squared. -40x. 5 times 5 is 25. 5 times 10 is so 125. Yeah, we're done. Now we simplify. X cubed. -8x squared and +5x squared become -3x squared. 25x and -4x is -15x. plus 125. So what I have on my note, I have something different. I make a mistake somewhere. No, I didn't make a mistake. No. Is that what you have? Yeah, I think that's what I have, yeah. We did this before. I don't know that you remember. We did this before. 2 lectures ago. The last problem of that lecture. I give you real solution and then you just kind of put them together and FOIL it. All right, last one, and we call it a day. Number 7 is your U23. Again, you don't have to. U23. You have until Sunday night to do it. So I recommend you don't have to do it now. Wait till you finish the exam. All right, let's do number 6. Number 7 is similar to number 6. Now for me, like I said, I use my own rules. I don't follow the Descartes sign. It's too much for you, and plus you're not gonna be on the exam. So what I do, I just kind of cross those out. I don't need those. You know, having writing on electronically is kind of spoil me. I can make mistake and not worry about being messy. When I write paper, like, it's hard. Like I gotta be careful because I don't want to keep erasing things over and over again. It's kind of like autocorrect. I lose ability to spell now because autocorrect. Try all the zero. Remember we did this last time with real coefficient. Now we do with complex. Very similar process. So do you remember the first step? Find all the possible zeros, right? I'll write it down. Find all possible zero. Do you remember how to do this? Yeah, factor of a naught over factor of an, right? So locate a naught first. Your constant will be negative 18. So the factor of negative 18 will be plus minus 1, plus minus 2, plus minus 3, plus minus 6, plus minus 9, and plus minus 18. An is 3. Factor of an will be plus minus 1 and plus minus 3. And now you do P over Q. So that's your P and that's your Q. Plus minus 1 over plus minus 1 is plus minus 1. Let's do one thing at a time. Plus minus 2 on the top divided by plus minus 1. The whole thing is gonna, yeah, it's gonna be the whole line, right? Because you divided by plus minus 1. So let's rewrite that. What about the second one? Plus minus 1 on the top divided by plus minus 3 on the bottom will be plus minus 1/3 plus minus 2/3 plus minus 3 on the top divided by plus minus 3 on the bottom. That's plus minus 1. We already had this, so we don't have to rewrite. Plus minus 6 plus minus 3, that's plus minus 2 plus minus 3. So we have all that, right? So we good. So we stop. The possible zero. So those are possible candidates, right? So the possible zero. Now you want to find the real ones, or in this case, both real and complex. Evaluate a few integer to find the real zero. Usually I recommend try -1 and +1 first. Now it's not always the case, okay? It just come up regularly. It should come up often. That's why they say try 1 and -1 first. But again, it's not always the case. So when I try when I try, if you try, for this step, I wouldn't recommend you write down yet. Just do think in your head first or in your calculator. If I plug in 1, would it add up to 18 and cancel the negative 18? No, right? So I'm going to skip the 1, right? I'm going to start with the negative 1. Let me give you a happy ending because I want to have time to go over the exam. It gives you 0. You can do that on your calculator. Next, you're going to try either positive 2 or negative 2. Let me tell you, on your exam, you will have the polynomial of degree 4. Then how many divisions you need to reduce down to quadratic? 2 divisions, right? 2 divisions. So you need 2 zeros. We found 1. We need 1 more. If you plug in 2, again, it's not going to add up to positive 18 and cancel the last negative 18. So I'm going to move on to negative 2. And it turned out to be 0. You have 2, you stop right there, right? Because you had enough. Because the reducible, the last reducible factor will be quadratic. Then you can use quadratic equation to solve for that. What's the next step? Once I have my 0, what do I do? Yeah. Use synthetic division to reduce the polynomial. Sometimes I just call poly. Start with the negative 1 first. And then write out those. So I have 3, 5. Let me use 3. Make sure you write out every single coefficient of every single degree. I don't have any missing degrees, so I'm okay. 3, 5, 25, 45, negative 18. The first step always bring down the first coefficient. So 3 times negative 1 is negative 3, 2, negative 2, 23, negative 23. Did I make a mistake or something? Negative 3, 2, negative 2, 23. I hate it when I do that. Did I make a mistake? No, right? 45 minus 23 is, it's supposed to be 0. Oh, it's not 0. Negative 1 is not 0. Negative 1 is not 0. Sorry. I look at the note. I thought it was 0. I look at the negative 2. Sorry about that. Let's do it with the 2 first. That's all right. We do with the 2 first. The negative 2 first. It's a good thing. Once you know that it's not your 0, then you remainder is not 0, right? So 3 times, so negative 6, negative 1, and positive 2, and 27. Oh, we're lucky. Negative 49. I'm sorry. 54, negative 54, and then negative 9, positive 18, and 0. Let's write that down. So we have 3x cubed. You can start with the constant on the left. So negative 9 here, and then 27x, and then negative 1x squared or negative x squared. We're lucky. I'll tell you why we're lucky. We don't need another 0 because we can factor by group factor. It's not always lucky. We're not always lucky, but in this case we are. So what I'm going to do, I'm going to group the first 2 and last 2. What can I factor on the first 2? X squared. So what's left is 3x minus 1. What can I factor on the second group? 9, right? So 3x minus 1 again. Now you factor 3x minus 1 out. What's left is x squared plus 9. See, that's what I meant by we lucky. We didn't need another 0. And then don't forget your other one will be what? Well, we have x equal -2. Now let's solve for this. Either I have 3x minus 1 equals 0 or x squared plus 9 equals 0. X equal 1/3 or x equal plus minus 3i. Yeah. You saw this in number 1 at the beginning of the class. And don't forget, our very first solution will be x equal -2. How many solutions do I have here? 4. Right, 4, which is match up with the function with the degree 4. Yeah. So similar to your exam, except your exam or real number. Now let me go to the so pick out your review. I'll mark the problems you should be focusing on. For version B, I want you to focus on number 1. And same thing with version C. So version B and version C focus on number 1. I'm not supposed to be